Last step, ETC in chemiosmosis. Alright, why does it make sense that protons would be pumped in between the two membranes rather than into the matrix? What we're headed into is photosynthesis, and we're going to basically take this picture and flip it upside down, which can be a little confusing. So it's important that you understand that in the mitochondria, the matrix is this big space, right, in the middle, okay? The intermembrane space is between those two membranes. It's a smaller area. So would it be easier to establish a high concentration if you were pumping a bunch of stuff into a big open space or pumping a bunch of stuff into a tiny space? Well, it makes sense that the protons are being pumped into a smaller space to build up a higher concentration gradient. All right, the next question says, what types of solutions have a high concentration of H+? I couldn't resist. I put the in there. So I'm bringing back some of that chemistry. We've got a bunch of H+ up here. Acids also just happen to have a high concentration of hydrogen ions. Bases are high concentration of OH negative ions. So in this case, you would expect the pH of the intermembrane compartment to be more acidic than, say, the matrix, or even definitely probably than the cytosol. So just a little extension there, application type question. Now, what is the role of oxygen in cellular respiration? We know that it needs oxygen, and here it is right here. Oxygen is the most electronegative substance that we have in this system. Each molecule in the electron transport chain becomes progressively more electronegative. That means that that's what's pulling those electrons from protein to protein to protein. And oxygen is there at the bottom to catch them, right? So the role of oxygen is to be what we would call the final electron acceptor during cellular respiration. Now, what would happen to the electron transport chain when there is no oxygen? So they may begin, the electrons may begin to move, but once they get to this last molecule, they have nowhere to go. So if that one can't move, then we start to get a traffic jam. These guys all get stuck. And so when these guys get stuck and they stop moving, that means these pumps shut down. That means that we stop pumping H+ into the intermembrane compartment. Next question up at the top says, so then what happens to ATP production? Well, without that concentration gradient, right, fewer and fewer H+ will come back through ATP synthase. And if there's fewer and fewer hydrogen ions coming through ATP synthase, that means that there will be less energy to produce ATP. So ATP production will begin to fall, right? Now, so that means that we've shut down this whole system. Okay, so then let's come over here, because another question from the top says, what happens to the matrix reactions in glycolysis? Well, if this is all backed up and shut down, that means that NADH has nowhere to deposit its electrons. So NAD+ are the empty taxi cabs, but there's only so many of them. There's only so many taxis in New York City. Once they all become full and occupied, they're just driving around the city with nowhere to go. They never drop off their passengers. And so if Krebs and matrix reactions don't have, let me back up, any available taxi cabs to come swoop in and pick up their electrons, then this whole cycle shuts down. And if this whole cycle shuts down, then pyruvate doesn't get converted, right? And again, these electron carriers are most likely headed to the electron transport chain. They could go to the route of fermentation. We'll get to that later. But pyruvate can no longer diffuse in because it's, going to build up and back up and it can't move, right? And then we have this high concentration of pyruvate. We've got a low concentration of ATP because we've stopped making all that ATP. And so remember, when you have a low amount of ATP, that means your AMP levels are probably pretty high. So you're going to start to stimulate the enzyme phosphofructokinase screaming, saying, hey, we don't have any ATP. And so then you're going to start to burn through more and more glucose, but it'll be all for naught because of that one little oxygen right there. Kind of crazy, huh? Okay, so then last question. How is ATP made during chemiosmosis? So it's different from what we talked about with substrate level phosphorylation. This one is known as oxidative phosphorylation. And so it is using this enzyme, and it is directly adding an inorganic phosphate that's free floating onto the ADP. So we're not pulling a phosphate off of a substrate. It's just there, so to speak. And then that's how ATP is being produced. So they're both making ATP, but the way in which it's happening, and by the way, matrix reactions, I forgot to mention, this is also substrate level phosphorylation. The only one that's oxidative is in chemiosmosis.